Okay, so we are recording the meeting. Hey everyone, so welcome to the last session, the fifth session for your course, Python for Data Science. My name is Raj and I'm a PhD student at IISc. We'll do like a brief revision of the syllabus, small points that are there, and we can take up questions one by one. Um, sorry. So Shweta, you can ask this on the discussion forum. Again, we have no idea on the um, exact details of how the exams will go on and all that. Okay. Um, okay. So we'll start with the first week. So we'll start with week after week, and let's see. I mean, I hope we'll have a lot of time for the week 4 because I think that's a bigger part. So week 1, any questions? If anyone has, you can just unmute yourself or raise your hand and I'll call upon you. Um, any doubts in the first week? So what all, see again, questions regarding exams, when it will happen, how it will happen, all of that. Again, we have no clue about that. Please ask your questions on the discussion forum. Okay. Um, Yeah. The first week we had this variables and data types and operators and all of that. Uh, what is the way to find the data type of a variable in Python?
Type of function.
Type of function, right? So type of will give you the data type of the particular variable that you have, right? Um, uh, what is operator precedence? Where is it
It will
used
take
basically? Where is it used? Operator precedence. When does it come to use?
that will tell you that which one has the highest priority, which operation has the highest priority, and which one has the least priority.
Correct. Yes. So while we're doing the expression evaluation, we'll get to know which one has higher priority. So those things will be that are done first, and then the other smaller priorities will be done, right? So, so a simplest example, let's say, um, if I have something like 3 plus 4 into 5, what will be the answer for this?
23.
23, right? It's not going to be 3 plus 4, 7 into 5. It's not going to be 35. It's will be 23, right? That's the idea. Okay. So then, um, uh, any other doubts on variables and data types? What rules do we have for naming a variable? Can I name a variable something like this? Let's say underscore ABC. Is this a valid variable to be defined?
Yes, it is.
Yeah, who said it is? Yeah, you're correct. Underscore ABC is fine, right? If I have something like 2 ABC, is this fine or not?
No, it's
No.
not. No, sir.
This is not fine, correct? You can't start with a number, but you can start with any letter or underscore. Both are fine. Okay. If I define a variable something like underscore 2AB, what about this?
It's fine.
It's fine, right? Just the starting has to be proper. That's the main point here. Okay. And also it cannot have any other characters. For example, you cannot have hyphen, you cannot have minus symbol, you cannot have dot, all of that, right? Those are not allowed. Um, What else? Hmm. Setup and all, I'm not going to that. Okay, fine. Shall we move to week 2? No questions here? Fine. So, uh, what all types of sequence data types do we have? Am I not sharing my screen?
No, it's not visible.
Ah, is it visible
Yeah, it's
now?
visible. Yeah, it's visible.
Okay, perfect. Yeah. Um, yeah. So, different kind of sequence data types. Can anyone name a few sequence data types?
Yeah, tuple list, dictionary,
Tuple, list, dictionary. Okay.
set,
Sorry. Uh, yeah. Set. What else?
String.
String. Yes. Okay.
Arrays.
Array. Yes. Correct. Array. Anything else left? Hmm. Now, in this, which of these are mutable?
except the tuple and the set all are mutable. The string is also not.
Right. So tuple is not mutable, right?
Yes.
List is mutable.
List is mutable. Yes.
Dictionary.
Dictionary values are mutable.
Right. Yeah. So see, when we say dictionary being mutable means dictionary as an object, can you add items? Can you delete items? Okay. So if anybody, so if a question says that, okay, is dictionary mutable data type? The answer is yes. Okay. Yeah. So dictionary is mutable. You can add, you can delete, you can replace things in a dictionary. What about set? Set. Can we add
Immutable.
items to a set after creating it? Sorry.
Immutable. Set is immutable. String is immutable.
String is immutable. Array. Set is mutable, right? You can add elements to set. Correct. And what about array?
Array. Mutable.
It's
Array is also
mutable. Mutable.
array is mutable. Correct. Now let's talk about, let's say if I have to do the elements of tuple have to be of the same data type or not? Same data
No, need
type
not to
and
be.
string,
Need not to be.
right? So need not be, right? It can be a collection of any kinds of elements in the tuple, right? What about list?
The same.
List also
It
same.
contain, yeah.
Correct, right? Dictionary. Now here we need to be a bit careful. Dictionary, what do we have any constraints on the data type it can take?
Yeah, values can be anything.
Correct. So here we have to be careful. We'll say values can be anything. And what about keys?
These should be numbers,
Correct.
strings.
Yes.
It should be hashable one.
Correct. Yeah. So keys in dictionary should be ideally hashable. If you don't know hashable, it's fine. The idea is that basically things like your any number, it can be integer or float. Okay, it's fine. Then your strings are fine. Okay, and even tuples are fine.
Yes.
Okay, so these all values are allowed in a as a key in a dictionary. Okay, now what is not allowed basically then becomes your um, let's say this is allowed. What's not allowed is basically hmm. What's not allowed is basically your things like set you cannot use. You cannot use a dictionary as a key again in a dictionary, correct? Then you have list you cannot use and so on.
Any
Okay.
mutables are not allowed.
Any yes, correct. So anything which can be changed that is mutable by definition will not be allowed. Okay, fine. So keys, be careful here. Okay. Next, what about set? Set can have different elements in it as different types in it.
Yes, it can be.
It can be right. A string.
A string can have, I mean, numbers and as well as in the alphanumericals. Yes.
So string, the type of information that can be present in a string is a character, any character.
Yeah.
Right? So it does not allow any other data type. So it's only single data type. It's only, it has to be a string, I mean, character in it. Okay, fine. Arrays.
Arrays can be,
One
I
data
think,
type.
yes, it can be anything.
Does anyone object to that?
Only one data type. Array can
Only
have.
one data type. That's correct, right? Only one data type. So whatever
Oh,
you start your, I mean, you create your array with, right? So for example, if you create an array, something like this array of I, right? So I will make sure it's an integer, and then you can give some 20, 30, whatever, right? So this will make sure that all the elements in the array A have to be integer. You cannot set the values to be anything else. Okay.
It can have any type of data type, right?
I'm sorry.
It can have any type of data type, right?
Yes, yes.
Oh,
Oh, sorry. Oh, I'm not. You're right. You're right. You're right. So set can have any type of data type. That's correct. Yeah. So only strings and arrays basically have that sort of this one, and dictionary values keys have some constraints on them, but again they can be of different data type. That's fine. Okay. Fine. Any other doubts, by the way, in this part of this one, sequence data types? Okay, fine. Shall we go to week 3? Week 3, pandas data frames got introduced here, correct? And how do you read data, etc. So shall we? So we'll do first the control structure. So what sort of control structures are present in Python? If you have to, so for looping, what all things are present?
For loop. Which statement? Which for?
Is it which?
No.
Sorry, while, not
While.
which.
Correct. Yes. So
Okay.
while, then for.
Or
Correct. Anything else? This is for looping. Correct. Let me just move this here. Yeah. For condition checking, conditions and all that.
if elif,
If else, elif.
Correct. If else and if else elif sort of construct can be used. Sorry, if elif, not if. So it's if elif else. Correct. Okay. Then uh, I don't remember. Have they covered break and continue sort of things here? In control structures. So if it's not covered, you don't worry. Most likely it won't be present. But if it's covered, then those also are ways to change control from one place to the other. Correct? Okay. So things like basically break and continue. This is mainly basically used when you want to stop your loop in a different manner, right? Than it's basically coded for, right? That's the idea.
Raj, where does the pass fits in?
I'm sorry.
Where does the pass fits in?
So pass is basically something like no operation. So when you don't want to do anything in that particular condition, right? So pass basically means no operation, nothing to do. So pass is more of a convenience that rather than any control, stuff here. So by pass, we are saying that so pass is executed. That actually means just nothing. That's it. Okay. Is that clear?
Yeah, basically it helps in prototyping. Okay, got it. Thanks.
Yes, correct. Okay. Um, then yeah, so in your pandas data frame, let's think about how to do EDA, exploratory data analysis. So if you want to get the count, how many elements are not null, how would you go about doing that?
Is
So let's
null.
say I have a
Describe.
what?
Describe will give that.
Yes. So yeah. So DF, let's say, has is a data frame. Okay. And I want to be able to use, let's say, get the column or non-null counts of, let's say, some columns. Let's say columns are A, B, and C. Okay. So for, let's say I want to get the number of values which are not null in the column A. How do you get that? Somebody said describe, but describe will give you for all the columns, right?
info info.
Uh, take the column, then do is null dot sum.
Correct.
Then
So
check how
DF,
many nulls are there.
correct. So DF of A, if you do, and then do dot is null, right? And then sum, how do I do? Dot sum,
Dot
Yeah,
sum, then bracket.
dot sum,
that will
right?
give the null values thing, right? But you ask
That will
that
give
how
you the
many
null values.
non-null values.
Correct. So this will give the number of null values. How do I get now the number of non-null values? Either this approach or any other approach. Anybody
Is not
has
null.
that?
Yeah, you can minus with the length of that column.
Correct. One option is that, right? So let's say you get this number as n. You take length of df. So length of df gives you number of rows in the data frame. Correct. So minus n will give you the number of not null values. What other option is there? Any other options?
We can do if is null is false. Can we do that?
Is null, is false is not there. That sort of a thing is not there.
I mean
But you're on the
Not
right
null,
approach. I mean,
to false. Right?
dot not null and dot sum. Yeah.
dot not null. I think yeah, dot not null exists. I
Is
think.
not null,
Just a
sir.
moment. Is not null, is it? Just a moment. Let me just check that also.
Not null is there.
So let's say pandas frame it and two is pandas.ma 3. So df dot not null. Yeah, it exists. So df dot not null will give you everything we want for, let's say, column B. Okay. Yeah, that's it, right? So this will give you the not null, each element whether is null or not, and then you can just do a sum of that. It'll give you the number of null elements, not null elements, correct? Or the other approach that you were talking about, that is basically your you can find the number of null values and then subtract from the length of df. Anything is fine. Okay. So dot null, not null is also fine. Dot not null dot sum. Okay. Then let's say I want the mean of the value of the values in column A. How do I get the mean?
Dot mean of.
Dot mean of, that's it, right? Dot mean will give you the mean of the values here. Does this mean consider null values or not?
No.
It doesn't, correct? So let's just see that in action. So df of b dot mean. So when I say it considers or not, it's basically mean is basically what? Sum of all elements divided by the number of elements, correct? So here sum, obviously you can't have the NA null value being summed. It doesn't make sense. But when you count the number of elements, that's where this mean can get affected if it is not considered or considered, right? So here you remember 3 plus 5 by 2 it's taking, so you get 4. Otherwise, if it counts pandas or not and not dot NA also as an element, then it will be 3 plus 5 by 3, correct? Which is not the case. So it doesn't consider null values in the mean. Okay. Now this is in case it's a, uh, a, what do you call that? Like a continuous value, right? If the column A contains continuous, values, some numbers for that matter, you can compute mean in that case. When you want to understand more about a column which is a categorical sort of a thing, right? Something like strings or something, some objects or something like that, then what things can you do on that column? You can't do mean, obviously, right? So what else can you do to understand how the column looks? What does the column have, and so on?
So, sorry, could you please repeat the question?
So when a column has categorical, that is, strings or some other objects and all of that, what sort of things can you do with that
You can
column?
do the
Mean,
mode.
obviously.
You can do the mode.
Mode, correct? So how do you get the mode?
Dot mode off.
Dot mode of. Just a moment. Yeah. So let's do that here. Right. So df of a dot mode. Does it? Ah, so it's giving something very weird. Yeah. So here, two is the mode of this column, right? Which is a string, basically, string column. And who is talking?
Okay.
Please keep your So please keep your mic muted unless you want to talk to the group. Okay. Um, fine. So yeah, so your mode here basically is 2, correct? So that's the way you can get the mode. How do I get the number of unique values and their counts, basically?
We
Basically,
can
the whole.
dot
Unique
unique of
function.
dot unique of function.
Sorry.
Dot unique of function will give the unique values,
Okay.
and value I
Value count.
underscore counts of will give the frequency.
Sorry.
Value underscore counts
Value
will give the
underscore counts.
frequency of the unique values.
Correct. This will give you the frequency of the unique values, right? Okay. Um, what else is here? Oh, yeah.
Raj, I have one quick question. Sorry to interrupt.
Yeah, go
So
ahead.
suppose if I have 5 rows, let's say that I have 5 rows, right? And if I drop the second row, so is it a best practice to reset the index as a part of the EDA, or can we keep as it is?
So that depends on what your index represents. So for example, let's say if your index is something like let's say some subject ID or some user ID, right? So then obviously resetting it will not make sense because you want to be aware that that particular user is no more present in your whatever you're going to do going forward. But let's say if it is some sort of thing, like for example, it's just a number of rows, sort of an index, then you can reset, not a problem, right? So again, EDA, we are more looking about the columns related information. Index doesn't matter as much when you're doing when you're planning to do EDA. Okay.
Okay, got it. Thanks.
Okay. Yeah. So this basically goes into the idea of how to deal with missing data, right? So let's say when you so when you have some missing data, for example, when in a numerical column, what is one way that you can fill the missing data?
We can do with the mode if it is a categorical variable, or we can go with the mean if it is a numerical variable.
Correct. So if it's a numerical, you can go with mean. Otherwise, for categorical, you can use the mode function. Correct. So this will basically fill in the this one, right? And how would you fill that up? So let's say, for
Uh,
example, now I want to fill up column B with the mean of the elements in B. How would I go about doing that? Anyone can give me the code?
Fill any function. Fill
Yes. Fill NA. How? Next, what do I write here?
We need to give that the data frame, the column dot mean of, or
Yes.
the mode of.
So here, what will it be? I want to fill in B column.
Then it should be so B is a okay. It contains the numerical, right? So we can give the df of B dot mean of.
Dot mean. Correct.
Yeah.
And is this enough?
I mean, in place equal to true.
In place equals to true. Okay. Anything else needed here?
Yeah, access equal to I mean, that is for the all the rows, right? So we need to put the access equal to the values, either zero. I mean, zero for all the rows.
But it's for all the rows, right? I mean, why would
Okay,
you?
okay. You bring it for only for the B row. Okay, got it. Thanks. Yeah,
Right. Is this enough? Anyone has
yeah.
anything else to add?
I think it should be enough of
That
the.
DF of column A.
Sorry, somebody had
Just
some.
check between both column, no, A and B, not only in B column.
Correct. That's exactly
DF
what's
of
happening here.
B.
Correct. Even A has some pandas, some null values. Even that's getting replaced. So how do I make sure it's only the B column that should be filled?
We can use the
DF in
subset.
square bracket.
We can use the subset or something else is there, so that we can specify the particular row in there.
assign this statement to df.
Assign the statement to DF of B.
Yeah, we can do that. We can do that in that way. Or if more number of the rows that we need to fill, then we can
That's wrong.
the set subset function is there.
That's wrong. That's wrong. Just remove the equals to and DF part, which will work.
Yeah. So once again, Partha, can you go ahead? You've been trying to say something.
Yeah, I have been interrupted by this section a lot of times. So just remove the equal to and DF. It should work. Equal to and DF of in bracket B, in square bracket B,
Here, just a
in square
minute.
bracket column.
Ah, I don't know why. Behaving very badly. Yeah. DF of B. Is this okay?
I think it will work.
Okay. Let's see if this works. That's it, right? So we're saying in that particular column, you fill NA with whatever value I provide here. Okay. And I'm making sure it's in place equal to true. It makes sure that whatever you wanted to do, it happens in that B column itself. Somebody was saying you assign it to this one. That is correct. If you want to do something like this, right? So you don't give the in place equal to true option then. Okay. This will also work. So your B is now filled with the me. Okay. So either of them is fine, depending on how you want to use in place of.
Or
Okay.
you can use the location as well, right? Lock, LOC.
But LOC, how do you want to use LOC?
to fill a particular row.
Okay.
Like more than, like say, for example, I want to fill it more than one row, that is B and something else C together.
Mm.
I can use that function, right?
How would you use that? Let's say if I do something like this now. Okay. How do I do that?
Okay, then the first row, the df.log of will give the first one with the rows information, colon the column information, right? We can put
Yes.
the rows, whatever the rows that we need to fill it up. I'm not sure. I'm just correct me if I'm wrong. We can
Okay,
use
fine.
that.
So basically, when you want to when you want to use df.log, so log is basically going to filter your rows in some sense, correct? So now let's say I will do something like this. I'll call it first b mean. Okay, that is the value that I want to impute, for example. Okay, and then I want to, let's say, fill in all those rows where b is null, correct? So how do I get the rows in which b is null? How do I get that? We discussed this, but just anything like that. Any how do I get that? So rows in which b is null. How do I get this? So somebody had said,
df dot is null.
correct.
df of b dot is null.
Right. So your is null basically gives you a series again, which has true or false in it, right? Based upon whether the value is null or not, correct? So hence, so when we did dot sum, so it basically just counted the number of elements which are null. Okay.
We can do one thing. We can
Who
அதே
is
மாதிரி 15 16 2 நாள் ஆக்டிவிட்டி பண்ண போறோம். அதுக்கப்புறம் எஸ்ஆர்எம்ல பண்ண
df.log, and then you have this. So then what happens is, so this selects all those rows in which b is null, right? So this is the row selection part. I don't want to fill all the columns. I want to fill only the b column. So that is done by this of b. Okay. And what value do I want to fill? I want to fill the b mean value. Okay. So does this make sense? Yeah. So the log is okay. So by the way, log is not a function. It's more of a indexing, like how you do when you use dictionary, right? You insert these A3, it's a D of A. We're using a square bracket, right? So it's more of indexing idea. Uh, so here dot log basically tells you use this particular, whatever the first column, whatever the first argument here is, variable here is, right? To filter out the rows in that particular way, right? So if it's a Boolean array, which is what this will give you. So this basically works as a filter. It'll select those rows in which B is null. Okay, that's the idea. This is how you get it. Fine. So again, see, you can do this in multiple different ways. This is one of the other ways. Fine. So again, similar. It'll be very similar when you want to do things like your mode imputation, right? So you just change this mean with mode, and you'll get that similar sort of an idea for categorical variables. Okay. What else do we have here? Yeah, so data visualization. So let's say I have um, a set of X and Y pairs, correct? X and Y pairs, for example. How can I visualize this X and Y values? What sort of a plot would you have? Sorry,
Scatter plot.
scatter plot, right? So yeah, so scatter plot basically will be a best way to visualize these X and Y pairs, right? So let's say if I have just some values of X, right? Some, let's say X1 to some multiple such values of X as a list or array or something like that. Uh, and I want to see how, like, what X looks like, right? So how would I then, plot X? What sort of plots are
East
useful to
plot.
understand the distribution of
East
X?
plot.
Plot.
East plot.
His plot, yeah, correct. So his plot basically gives you the histogram, correct. So it will basically tell you in which particular, window of, let's say, X values, how many values are present of which are the similar sort of a number of that range, right? What are other ways you can use? So histogram is basically a very detailed sort of information, because going to get one for each range in the X range values, how many values are present. What other ways are there where other than histogram?
Count plot.
Sorry,
Count plot.
count plot.
Yeah.
Uh, I mean, isn't that histogram? What is count plot?
Count plot will give the like, for example, if it has a unique value, right?
Yeah.
And it will give the number of frequency of those values in a bar.
Bar plot. Okay. Yeah. Yeah. Okay. Sorry. Yeah. Bar
SNS
plot.
dot count plot. Yeah.
Correct. Yeah. Bar plot. Yeah. Count plot. Yeah, that's correct. Right. So this will give you for each unique value in X, how many such values are present, right? So this is even more finer than histogram, because this will basically give you in a range, and this will give you for every unique value. Correct. So can I do something even bit more coarse, a bit more not not more detailed? So it's bar plot is the most detailed one. Then you have histogram. Then what can you do? How do you summarize a histogram for that matter? Let's say if you have to think about that.
Sorry, Raj, can you please repeat the question?
So how can I get even less finer details, right? So let's say histogram is has some finer information. Bar plot is even more finer information. I want to go in the reverse direction. So bar plot has more information than hist plot. Then what what could be here?
A ridge plot.
Ridge.
Yeah.
Box plot.
Box plot. Yeah, correct. Right. So box plot. So box plot, or basically box and whiskers. You can use this. Correct. Box and whiskers plot. So this will basically give you the, let's say, the what is the median, what is the interquartile range, and some values which are, let's say, very far apart. Then what is the what sort of values are present, and how much is their frequency, I mean, in general, with respect to the other values. Okay, that's your box plot. um and then yeah, so mo even lesser finer details if you want, then you'll just end up going with mean, median, and stuff like that, right? So just simple quantiles and information about that. Okay, so that's, I think, about data visualization. um let's go to week 4. So there was some questions, but before, one second, we'll go to that.
Raj, I shared a few queries
Yeah.
through mail. So could you please, if
Yeah,
time
yeah, yeah.
permits.
Yeah. We'll get to that right now.
Thanks.
So function in old codes in the eights in the case studies. Again, please ask on the channel. Just a yeah. Learn all the equations for the exam again. Exam formats. I have no idea. Um, yeah, that's correct. Okay, so in week 4, so there are a couple of questions I got before the class. So we'll just we'll do that one by one, and then we'll go for any other questions if people have. Um, just a moment. Yeah. So in this case studies that were there for classification, regression, and all that, so there were a couple of variables that were present, and they were discussing, what those variables represent and how to clean up the data there. So one question is that, for example, let's say year of registration and kilometer indicate high collinearity. Why did we not go clubbing these variables, right? So I'll just, yeah. So year of registration and kilometers, right? So again, see, this sort of idea makes sense, right? For example, let's say the older the car is, the more number of kilometers it will have on it, correct? So basically one variable can inform a lot of the information about the other variable, right? So this is sort of basically we're talking about collinear or in a sense correlated features, correct? So the question was, why are we not combining these variables? So how would you even combine?
Yeah, we
if we
can
have to-
we can use it as a usage rate kind of a thing, a new variable, like how we combine year of registration and month of registration. The same
Okay.
thing, because the VIF factor is more than 10 for year of registration and the kilometer, the one that the table that I have shared with you through mail. So if it is more than 10, then it is definitely a multicollinearity. So either we need to drop one of the column, or we need to club that and make it as the third variable with both of the things.
Right. So that is one thing, of course, I mean, you can do that. But can you think of anything else that, for example, let's say kilometers might not give that information about, but year of registration might give that information? So see, again, the idea here is that obviously when you have features which are correlated, they can be a problem unless if you handle them properly, right? But the idea is that sometimes what happens is when you have two variables which are correlated, unless they have like a perfect correlation, it's possible that some of the variables can have some other effect, some other information which is important for the prediction and not present in the other variable. Okay. So generally speaking, you keep all the variables and you see whether you can, so when trying to understand how much a variable contributes to the problem at hand, that's when you have to be careful about this features being correlated. Otherwise, ideally, you can keep both of them. It would be useful because in case the problem requires one of the variables clearly than the other, then it can become a problem if you combine them. Is that okay?
Yeah, but thanks.
Yeah. So there was one other question regarding the price range sort of thing. So where, for example, there was a filter applied on the price range where the price range was taken to be less than 1.5 lakhs, I guess, right? So again, so we discussed this last time. The idea is that um, you want to be able to keep your variables in a sensible range, right? Now, sensible is a very subjective measure. There is no way to clearly define that. In fact, there's no way to clearly define an outlier also, by the way, till now in data science. Okay, so it depends upon what you consider an outlier. So in that way, the people I mean the course videos, they have taken 1.5 lakhs as a maximum value for your price variable, but you can take it to what level you want to predict. Okay, it's again a very subjective. It's a judgment call that the person who's trying to predict or use it depends on the.
Yeah, but sorry,
Yeah.
correct me if I'm wrong, but that will create either high right skewed or a left skewed, right? If we include the huge outliers, like
Yes.
1.5 lakhs kind of a thing, right?
Correct.
So that will impact on the model prediction.
Yes. It will impact. I mean that is going to be the case. And the point is sometimes sometimes the data will be that way. Right. So I'll give you an example. For example, let's say so I work in this cognitive behavioral data and all of that. So where you measure, let's say, reaction time of some person. Okay, how much time they took to react to a particular item on the screen or something like that. This data is generally speaking skewed, right? So you will generally have something like this very sort of long tail distribution. Okay, so then what you can do is you can say, okay, no, I will only look at only this amount of range in my data, but that doesn't make the problem go away, right? If you want to understand the variable like a reaction time, you have to deal with the fact that it is skewed and try to take steps to understand that there is skewness. So how do you attack it, or how do you solve for it? So one general thing that people do when you have skewed data is you can apply some transformations like log transformation or box cox transformation, some stuff like that. So these transformations, they try to make your target variable a bit less skewed compared to whatever is present. Okay, and these transformations, they become moot if you're trying to use neural networks, which is not, I guess, covered in the course yet. But if you're using things like, for example, simple regression or classification problems, then these things will make a lot of difference. Okay, does that answer your question?
Yeah, got it. Thanks.
Yeah. Yes, this I think answers a lot of right skew, left skew. Yeah, all of these. Yeah, log transformations, you should ideally do it. Um, then you have, yeah, so numerical features having different means and standard deviations. So they need scale. So um, let me give a simple idea. Okay, so um, when you have like a linear regression problem, right? Let's say y is equal to some um, beta naught plus beta 1 x1 plus beta 2 x2. Let's say we'll have two variables. Okay. So the idea is, let's say if x1 is a value which is ranging from, let's say, from 10 to 1000. Okay. And x2 is a value which is going from 0 to 0.1 only, right? Very different scales of operation for of these two variables. Um, uh, do you think there is a need to make these two variables come in the same scale?
I think yes, to have that normal standardization kind of a thing. Yeah.
Why? If your problems, see, again, let's come to the so what is the problem you're trying to solve? You're trying to solve a problem of prediction. Okay, you want to predict y as accurately as possible. If that's your aim, then having these two being in same scale doesn't really make any difference. Whatever scale you change, those changes will be absorbed by the two betas that you have.
But I looked at the OLS assumptions for the linear regression, right? That is one of the assumptions that when we have the mixed the features, right, like means and standard deviations, specifically for numerical the features, right? The recommendation is to scale it so that we can get a more predicted output.
Yes. So the idea there is if you want to be able to understand the effect for each variable separately. So let's say you want to understand what is the effect of x on x1 on y, x2 on y, right? Then having them in the same scale makes sense. If your problem is so basically your problem then shifts from trying to do just prediction. From there, it goes into trying to see what the model has learned or what pattern is there in the data. Then you need them to be in the same scale. Does that make sense?
Yeah, got it. So, one thing is that, as you mentioned, that the skew can be mitigated using a log transformation, right? But however, when we look at this, the skew summary that I have shared with you, the price, power PS, and kilometer has a high indication of the right hand as well as in the left skew. So, but what we have done the transformation only for the price variable, but we have not done for power PS and kilometer. Is there any specific reason that we have not done it for those two variables?
Uh, so I don't remember the exact details as they're here, but uh, no, I think yeah. So to just to make sure your variables are in similar distribution at least, yeah. So ideally you would want to do these sort of transformations. That's correct. And especially when you're dealing with linear regression and for simple classification problems for neural networks it's not as much I mean there also there are some other issues there but yeah, so you ideally yes you would want them to be similar this one, so you should try to mitigate the skew in some way.
Yeah, got it. Because I got when I looked at the skew metrics, right? For power PS, it is showing it as 1.5, and for kilometer, it is showing it as minus 1.5. So there
Okay.
is a huge skewness for left hand as well as in right. But we have not tackled that, mitigated those things.
Right. Ideally yeah you should try to do it. That's correct.
Got it. Thanks.
um then yeah, so then any questions here? EOS count x-axis has wrong numbers from 0 to 10,000. What do you mean x-axis has a wrong numbers in this? Because so what is this edge plot?
Rich plot is same as the scatter plot. If we use the linear fit equal to
Linear
false,
regression
then
model bit. Okay.
scatter plot. If we use fit equal to true, then it will try to fit that. Otherwise, it is be the same as a scatter plot only.
Correct. So you're giving X as the year of registration, okay? And you're trying to plot the reg plot with respect to X, okay? This is cars data, is it? So cars data, I don't think I have it here. Uh, yeah, just a moment. Yeah. We can do here. Hmm. Let's see if I have C1. Okay. So DF is pandas dot read CSV of downloads. Let's see if it reads car sample of CSV. Okay, so we are able to read the data. Fine. So what do we have? We have year-wise counts. Okay. Data is cars. Okay, doesn't matter then.
I think we can, if we import that the code that they have shared, right, we'll get the graph directly.
Is this the thing that you're getting?
No, Raj, why don't you import the download the code which is available in the portal and then use it in the Jupyter lab so that we'll have the graph ready. We can
No, it's fine.
visualize.
No, we got the graph, right? So it's fine. So, but, so what's the problem? So, so math Arun Raj. I mean, so see, this is exactly what we're trying to solve in the data set, right? So whatever data you get from the real world can have these sort of inconsistent information in them. So that's exactly what we are trying to see here. For example, let's say obviously the year of registration cannot be more than 4,000 or cannot be more than the current date, right? So that sort of a thing we need to filter out. But um, so I think you've tried to filter, but you're giving the data as again cars only. So you need to give the filtered data. Does that make sense, Arun? So this is the filtered data, right? Or no? You're not even filtering it. So then you need to filter. Yeah. Um, so let's say DF. Yeah, you'll have to clean it. That's correct. So DF is, let's say, DF of DF dot year of registration is, let's say, less than something 2018, is it? Yeah, 2018. Correct. So then if you do that filtering and then do the same data frame, you'll see that okay, it's something like this, right? And then this brings out the problem on the other side, that obviously there were no cars during this amount of time. So then you can do something like let me just remove this. Yeah. So then you will have you can do a filter like this. So you say I want this filter and I want another filter, which is basically your lower bound on the year of registration, right? So which is basically less than 950, right? And this gives you the nice plot like this. Okay.
Raj, without filtering, can we do using X limit? That also helps.
X limit, yes. So I think this gives back the axis, right? If I'm not wrong. Yeah, it gives us.
We can mention like from 1900 to 2025, it will just plot that particular range so that we can get a better picture on that.
Yeah, but
I
how to
mean,
do that
that's
in
the
the
initial analysis to find out the range, right? So we can play around with the X limit with the numbers. So to figure it out, how where the outlier starts, what range that we need to consider it. Based on that, we can go ahead with the filtration kind of a thing.
That's correct. Yes, yes. That's correct. Yeah, but I'm not sure how to exactly in the same in this one line command only. But yeah, I mean that it's possible. It's a possibility.
PLT.xlim. The next line you can put a PLT.xlim
Okay.
after X of some range like 1900 to 2025.
Yeah.
That is before the graph. Okay, we can just do the plt dot show.
So now plt dot show is it again?
Yeah.
So you're saying, but don't filter though. That's correct.
Yeah.
So this is the previous one that's having all of the issue, but plt is not defined. So you need to again import matplot lib dot plot as plt. Is this correct?
Pie
Sorry,
plot.
pie plot. Sorry, yeah, pie
Pie
plot.
plot.
Yeah. So then you get this.
Yeah. So yeah, we got the box. Now we can go and use a scatter or edge or whatever it is to populate the values. So that would be more readable kind of a thing.
Yeah. Yeah, that's correct. We can do that. So let's say if I do this, and then you give what? But how do you make sure it's filling in the same block? How do you do that?
Before the PLT, you can put that.
So you can do something like this plot.figure, and then you get a axis handle. So basically you say that figure dot, let's say, subplots, whatever.
Yeah.
This gives you AX as the handle, and you can now do AX dot set xlim. There's exactly this sort of a thing here. Correct. And then you can ask Seaborn to do the plotting inside this axis, right? And I think Seaborn has a AX. Doesn't. Shabash.
I just pasted the code that I have used it.
Oh, yeah, here. So X. So AX equal to X. I guess this is.
Yeah.
Yeah. This is how you will get it. That's correct.
Yeah, that's for subplots. Yeah.
Fine. Okay. So anyway, these two ways to plot the output. Yeah. Okay. Anything? Yeah. Anything else? Anyone has any other questions? We still have an hour left. So regarding reading data, any issues in reading data? How do you read the CSV? How do you make sure your index is correct and all that? So let's say now this is the CSV that I have, right? If I want, for example, the name to be the index, how do I make sure the name is the index?
We can use the index option, right? Index equal to
name.
Index equal to name.
I'm not sure the exact syntax, but yeah, we can use that. Index equal to something. Let me try it.
Equal to.
Yeah, go ahead. Somebody had a question. Go ahead.
I may have to drop. I think there won't be any end of class announcement, right? It will be just a public announcement. I can drop public.
I'm sorry, I can't hear you, Apartha. It's a bit unclear.
Will there be any end of class announcement, anything related to exam, nothing? No? This is just a public announcement. I may have to drop now. That's
You want to drop out right now? You can drop because we record the video.
there won't be any announcement at the end, right?
No. There are no announcements here. No. There's no announcements here. Yeah. Okay. Yeah.
Excuse me, sir.
Yeah.
Sir, sorry for the interruption. Where we can find the recordings?
Yeah. So recordings are present here. So this is your portal, right? From the NPTEL. So you can go to problem solving session 2025.
Okay.
Right. So click that. You have here, and this is the Excel sheet which all the TAs fill, right? So which has a YouTube link. So from every week, each week, whatever we have, recorded, it's all present on YouTube. Okay.
Okay, sir. Thank you.
Yeah. In the exam, from the supplementary videos of this one mathematics pass or just the state case studies, again, no idea. Please ask syllabus related questions on the group. Yeah.
Excuse me, sir.
Yeah. Go
Sorry
ahead.
to interrupt again. And the thing is, like, you will be going through the revision of linear regression models and all, right? Like about the week 4 topics.
So we can do that. I mean, you guys want that, we can do that.
Yes, sir. Like after this doubt session, or at least like following with the like overall summary with like equations slightly, so that we'll
Okay.
be having some confidence for that sake.
Sure. We can do that right away, actually.
Yes, sir.
We-
Please, could you please continue with that, and so that like we can carry on with same doubts after this small session about linear regression and all, like week 4 sessions topics.
Yeah. Sure.
Yes, sir. Thank you, sir. Thank you.
So, yeah. So I'm not sure exactly what all equations they covered here, but I'll tell you what I know. Yeah. So in linear regression, okay. So when do we apply a linear regression? What between linear regression and logistic regression? What is the main difference? When would you apply one versus the other? Anyone? Linear regression versus logistic.
Yeah, linear regression is applied when we want to predict something, whereas the logistic regression is to classify the variables, right? Maybe like two categories or three categories kind of a thing. That's the category, and the first one is for predicting by the learned pattern. We can predict the
Yeah.
unseen. Yeah.
So again, both of these are prediction problems only, prediction methods only. The type of the variable is what we are, thinking about, right? So here we are saying that it's prediction of a continuous value,
Yeah.
right? Basically any real number for that matter. And logistic regression is basically something like you're trying to predict a categorical value.
Category. Yeah.
Right? And again, to be even more precise, this actually only supports binary. For logistic, it's currently, I mean, the way it's set up is binary problem only. So you only one or zero or true false, A or B. That sort of a thing you can do in binary in logistic regression. Okay. So in linear regression, the idea is, let's say you have a set of predictors, right? Or your features, basically. These you can call this features, predictors, features, or you can call them as independent variables in the context of the problem, at least, right? So again, these are all just different names of the same idea, that you're trying to use that to predict something. And the whatever you want to predict is, let's say, your output, I mean,
Target.
correct, output, target, or the
Dependent.
dependent variable. Correct, dependent variable. So now let's say you have, for example, let's say one dependent variable, we'll call that as y, and you have a set of predictors, let's say we'll call that with x1 to x m. Okay, x1 to xm, right? So linear regression, the idea behind linear regression is that it proposes that this y, whatever you have observed, that is your dependent variable, is a linear function of these predictors, right? That is basically so by linear we mean something like this. You say it's something like this. You say beta 1 beta naught plus beta 1 x1 plus beta 2 x2 and so on up till um, beta m x m. Okay, this is a the assumption of linear regression, right? So basically what you say then is, you say, okay, f of x is this guy, right? And my prediction, or I'll call it as y hat, for example. Okay, y hat, that is an estimate of y, estimate of the y that is existing actually present, and y hat is the estimate of y. So the idea then is you want to find out these betas. You have x's, you have y's. You want to find find the betas such that the estimated the estimate is as close as possible to the actual, that is y. Okay, so what you want to do is you want to say y hat minus y. You want to make this as close to 0 as possible, right? But the point here is that this particular error can be either positive or negative, right? So when I say I want to reduce this value, it can go to negative also, but we don't want we want zero. We don't want negative error. We want zero error. So for that, what we do is we simply take a square of it. Okay, so this becomes our function to optimize, right? Or we'll call this as, let's say, loss. Okay, and what is the idea? You want to minimize the loss. So you want to minimize. So the idea, the way you will set up this problem will basically be will basically be, you want to minimize the loss. The loss is basically your f of x minus y the whole square. Correct? Okay, and the and what you want out of this is basically the betas, right? So you want to solve for the betas. Solve for beta naught up to beta m. Okay, so is the problem setup clear? Right? This is the problem setup for linear regression. Fine. Now the idea is, so then how do you solve this problem then, right? So once you have this sort of a problem statement, how do you solve it? So let's say now I'll call this loss L as this f of x minus y. F of x, again, remember, is this beta naught plus beta 1 x1 and so on up till beta m xm, right? Minus y the whole square. Okay. Now the idea is you will apply, let's say, so again, going back to our usual, I mean, the way to, yeah, that's correct. So just a moment. Yeah. So so Math Arun Raj is saying partial derivative with this parameters, and we set that to 0, right? Doing justice to his first name, right? So the idea is, so the idea here is that, again, remember, when you want to minimize or maximize something, the point is this. Let's say you want to minimize something, at the minimum point in this, let's say this is your loss L, okay, and this is some with respect to some beta, let's say some beta I, right? So you want to minimize the loss with respect to some beta. So the thing is, at the minimum value, right, your derivative, that is your the slope of the line which is there at the minimum, the slope will be 0, right? Slope will be 0, and your second derivative, that is your the slope of the slope, right? The rate of change of the slope will basically be negative, right? Sorry, positive. Yeah, positive. Correct. So then what you do is you will now look at dou L by dou beta I. It's a dou beta 1, for example. Okay. Oh, sorry. Yeah. Dou beta 1. Correct. So now when you do that, apply your usual way of solving this problem. Here you have a function which is a function of beta and a lot of other parameters. But you have squared here. So you'll have 2 times beta naught plus beta 1 x1 and so on, minus y, and then derivative of this whole quantity, that is this whole part with respect to beta 1. So that's going to be x1. Correct? You'll set this to 0. Now you will do this for all the betas, right? Beta naught for beta m, beta n, so on. And you will then equate all of them to 0. You will get a final solution, which will basically be your beta. So beta star will basically be the one that gives you the minimum argmin. Argmin means basically what arguments are giving you the minimum value of all the betas, beta naught, beta m, of this function, that is beta naught plus beta 1 x1 and so on until minus y squared. Okay, is this clear? Who was the one who asked? Balaji. Does this help you understand what?
Yes, sir. Yes, sir. It's clear cut. Clear cut.
Oh, fine. So this is the idea of linear regression. Okay. Now, when you're coming to logistic regression, um, okay, shall we go into the probabilistic interpretation of the of this problem that we discussed?
Okay, sir. If you have the data set,
So,
then we can go with an example, a small one at least.
okay. So the problem, okay. So the probabilistic interpretation of linear regression, let's say, right? So here the idea is, you say that whatever y that you've observed, that is right, what you have in your hand is basically a Gaussian distribution, okay, with the mean being all of this beta naught, sorry, this function beta naught beta 1 x1 until beta m xm and some noise, some sigma squared noise. Sorry, yeah. Okay, fine. So then the idea here is you will say, okay, ideally you should write it as y given x, fine. Okay, so then what you will say is you will say, okay, I want to maximize the log likelihood of observing this y, whatever I have, observing y. This will basically be very exactly similar to what we have done this this thing. Okay, it will come to exactly the same problem statement. Okay. Fine?
Yes, sir. Yes, sir.
Okay. Now, yeah, example we wanted, right? So let's just, for that example, we can just go into code. Let's just yeah. So does anyone remember sklearn? Well, it's not necessary, but yeah. Yeah, let's just take this code and we'll see what is happening. Mm. What's happening? Okay. Just a moment, guys. Yeah. So here, what we're doing is we are setting up the regression problem itself in this way, right? So we're saying that there is a, you have two features here. Yeah, so let's do it that. So X here basically is a collection of samples cross features, right? So here you have 4 samples of this particular whatever Y that you observed, right? Sorry, X that you observed, and the different values of the features. So there are 2 features, right? So I had taken beta naught until beta M, right? So here M is just 2, right? So 2 features you have there, and the first feature values are here 1 1 2 2, and then you have 1 2 1 2 3 2 3. Okay, and then what you have is you have the y variable, which is basically again for each of the samples, what is the y that you observed, right? That is basically a 6 8 9 and 11, right? So your linear regression, that is function in this scalar, that is going to give you is going to try to recover this what is the relationship between y and x? Okay, so that when you do this dot fit, right? You'll get this reg model. And this basically has what all information? It has the intercept, I guess, first. So, yeah. So intercept is basically the beta naught. When we said the linear part, the non-changing part of y, right? So it's sort of like saying the mean of y when there's no x involved. So that's basically 3 in this case, right? And reg dot so showing up. So yeah, coef. Yeah. So reg dot coef. Correct. So this is telling you that whatever y you observed, the coefficient, there is the beta one basically, right? So for the first feature, the beta is basically 1, and the second feature, the beta is 2, right? So if you multiply 1 into the first feature here, 2 into the second feature here, and add 3 to it, you will get y. This is exactly what you're trying to learn from linear regression. Is that clear?
Yes, sir. Y is equal to mx plus c, that kind.
Y is equal to, that's exactly what we're doing, right?
Yes, yes.
And we have multiple x's, so we have multiple m's basically. That's the idea.
Okay.
Yeah. Okay. Bhumika, you have a question? Okay. Fine. Right. So this is the idea of linear regression. Now,
Good evening.
yeah, go ahead. Who was it? Yeah, go ahead.
Sir, actually, I have a question कि इसका when will the paper will happen of that course?
I have no idea.
Okay, thank you, sir.
Yeah. So just see the, whatever announcements you would get from that, you will get to know. If anyone here knows when is this one, just put in the chat so that will help out others. Yeah. Logistic is spam prediction. Spam prediction. Yeah, that's correct. We'll come to that. Based on historical data. Yeah. You're right on that idea that you want to predict based on historical data. So here historical is basically whatever data you have collected, right? So we'll use that only to understand understand what the betas are and all of that. And then when an unknown data point comes in, you will try to use that to you will use your model to predict the value, right? That's the understanding. So it need not always be a time series data as such. Here history just means basically whatever is already present with you, you will use that to create a to make the prediction for something that is unknown. Okay. Yeah. Extrapolation, that's correct. Yes. So you will try to extrapolate for something that is unknown, unseen maybe, right? Okay, fine. So that's about your linear regression. So logistic regression, the idea here is, let's say you want to predict between A and B, right? I mean, categorical sort of a thing, right? So let's say A or B. Okay, so how do we formulate the problem? So here what we'll say is we'll say that uh, the sorry, so we'll say here that your so we'll say here that let's say so this A and B are basically coming out of some sort of a random process. Okay. Um, so how many of you know what a Bernoulli variable is? Bernoulli random variable. So starting with the probabilistic interpretation, because that's sort of the easiest in a way to tell. So here basically, so So let's say you have a a coin, right, which you toss with heads or tails, right? So to be able to describe what the coin is doing, we can use a Bernoulli random variable, which basically tells you that the probability of seeing a heads, okay, is some probability, let's say some small p. Okay, so then by definition, the probability of seeing a tails is 1 minus p. Okay, so what we are so then what we say is that this so then this random variable which is telling you whether heads or tails is there, that's a Bernoulli random variable in some sense. Okay, again there are other things involved here, we'll not get into that, but the idea is this, that uh, you're trying to measure or trying to understand the probability of observing a head, right? In our case, when you want to do A or B, you will just say probability of observing A. Okay, and the assumption that is underlying this this particular model is that whatever this probability is there, this P that you see, that is a linear function of the features that you have, that is X basically, right? So then what you say something like this. So P of X, let's say, is a function of your is function like this: beta naught plus beta 1 x1 and so on, beta m xm. Okay, but what you observe is you observe the final variable, you don't observe the probability. Remember, you don't observe what P of X is, you observe H or your basically A or B's, correct? So for that, what you do is you use a sort of like a link function. So here you will say that your probability of observing A or one of the items that you have, A or B, right? This is basically your logistic, that is your 1 by 1 plus e power minus this P of X. Okay, is that okay? And then you try to minimize the what you can say log likelihood
Optimizing it.
observing. That's correct. Yes, optimizing, yeah, maximizing the log likelihood of observing whatever data you have, that is A or whatever A's or B's you have, with this probability. You will try to learn the betas, beta naught, beta 1, and so on until beta m. Is that does that help? So this is the problem setup that you have at hand.
Sir, the Bernoulli probability, like random variable, what you have explained, is it not the same like a binomial variable, like binomial random variable?
Correct. So binomial basically is a collection of Bernoulli random variables.
Okay, got it, sir, got it. It's one of the variant.
So I mean, so basically the idea in binomial is you're counting the number of times you got heads. So
Yes.
because in Bernoulli, the idea is you will do the experiment once and that's it. You got one head, or you got a head or a tail. In binomial, you do multiple of these Bernoulli Bernoulli trials, and you count the number of heads and so on. So hence you get this. So binomial distribution depends on two parameters. That is the number of trials you did, number of Bernoulli variables you have taken, and the probability of each of the Bernoulli random variable, right? Which is why you get this sort of a neat, that sort of a distribution where you say number of times you observe to be 0, times you get one time, two time, and so on. You will get that binomial factor, that what you call that NC X sort of thing, right? Those factors will come into picture. Yeah.
Thank you, sir. Thanks a lot.
Yeah. Single drive binary output for Bernoulli is useful for hypothesis testing. Yes, that's correct. I mean, you can do hypothesis testing on multiple different random, on distributions. But yes, for checking whether one is more than the other, you can do that. Yeah. So this is a problem setup that you basically get and you try to learn that probability as a function of the this features that you have. Okay, this is the main idea here, and it becomes complex because of this this non-linear sort of an function that comes in. So then you have to do something like gradient descent and stuff like that to be able to optimize it well. Okay, fine. So this is the general, knowledge on linear and logistic regression. Any other doubts? And yeah, so we can look at the example also, but it's yeah. Yeah, so let's say you have something like this. Okay. Yeah, load iris is basically, I guess, the
Dimensional reduction and penalty the same in ML regression model. Is dimensional reduction and penalty.
sorry, who is speaking? Is dimensionality reduction and penalty the same in ML regression model? No, they work in on different principles, right? So penalty, by penalty, I mean you're I think you're talking about the L2 penalty, L1 penalty, those sort of penalties. Um, yeah, so that is basically like placing a prior on the parameters. So now in then you say that okay, parameters themselves are some random variables, and you can place a prior. The prior is basically saying that some sort of a universal knowledge that you want to imbibe in your model, right? Dimensional reduction basically acts on the idea that whatever data you're observing, some high dimensional data that you have, that is actually coming from a very small dimensional manifold. So you want to be able to find that manifold because that's exactly what is the most important part of the data, not the actual data that you have. So both are different sort of ideas that come in. Okay. Yeah, so it's sort of like working with projections, but again, that depends upon what dimensional reduction you're using. So different things have different ways you will end up. That's correct. I don't know why this keeps dying. Okay. Any other doubts? Week 1 to week 4. We were on this one, right? Index column and all of that. Yeah. Okay. So yeah, enough about ML here now. So let's say we have this data frame, let's say cast sample.csv, right? And you want to be able to read the name column as the index, right? So how would you do that? What are different ways you can do that?
Put the
Even
index the column, like index is equal to 2 can make index is equal to 2 because name is the third column.
okay. So index, there is no index parameter itself. Do you mean index col, index column?
Index column, yes.
Right? So let's see if it works. Yep. Oh, that's coming as seller. Is it? So name is basically the second column, right? So it's going to be index column is equal to 1, right? Yeah. So here you can see now name is the index and other things are index based on this. Yeah.
Yes.
Okay. Uh-huh. And how do you find the type of different, let's say, some variable, some column? So for example, let's say price column is there. I want to see what type is that being read by the pandas column. How do you find out the type of the price column? df dot price dot d type, right? So df dot price dot d type will give the type of the particular column, right? So in this case, it's integer. Okay. For example, let's say if I check vehicle type, right, that gives me some O, that's object in some sense. Okay. So no other doubts. I think everybody's going to just ace the exam, I guess. Oh, we didn't cover NumPy. Yeah, so NumPy, we discussed this idea of dot product, right? How many of you remember? Let's say NP, NumPy is there, NumPy dot, right? If I want to do, if I give two matrices here, right? What is the output when I get dot? So let's say if I give A and B as two matrices, it's a two-dimensional array, two-dimensional NumPy array. What does NumPy dot NP dot compute? It'll compute the matrix multiplication of A and B, right? So it'll be A, B. That in general mathematics, what we talk about matrix multiplication, right? So this has to be, for example, let's say M cross N matrix. This is N cross P matrix. Then you will get this as a so you'll get as a M cross P output, right? So dot function basically helps you do that, right? Or you can do basically something like, so this can also be done in a different way. You can write as A at the rate B, right? So A at the rate B basically gives you the dot product, I mean, the matrix multiplication of A and B. Okay. This is sort of more standard, I mean, seen everywhere in multiple different libraries. So you can use that. Okay. And can you change NumPy arrays? What about NumPy arrays? Are they mutable, not mutable? So if I create a NumPy array, can I change the NumPy array entries? Is it mutable or not? So these are mutable, correct? So we can change the entries in the NumPy array depending on, let's say, whatever you have. Okay. No other doubts on variables and data types, operators? Operator precedence. So yeah, so you should be careful there a bit. Okay. So if they ask, for example, what is the order, what is the final output in if they were to run a particular or give you a particular set of operations, you need to be able to get that clearly. Okay. Indentations, yes. So Python as a language, it relies on how you indent the data to be able to understand where your block ends, right? So basically, let's say when you want to do multiple operations inside a particular for in a loop, right? So let's say for something you like A in B or whatever, and then you have statement one, statement two, and so on. This indentation, this space is what tells Python that, okay, I need to do both of these for every loop of A. Okay. Um, for example, Java, and I think in C also, yeah, C and Java and all. So there you have explicit ways of telling the compiler where the loop is starting and ending, right? That's basically done using a flower bracket, right? So there you will do something like for A in something like that. I mean, I'm forgetting the syntax here, but something you'll have like this, right? So, and then you can write your statements in any indentation you want. Statement one, statement two, and yeah, you'll have semicolons and all of that to be able to tell the compiler that this is the block that you want to do for every loop. Okay. In Python, it's the indent that tells you that tells the interpreter where the block is starting and ending. Okay. Okay. If there are no more questions, shall we end the session? So as I said, any questions regarding the exam, setting, all of that, please ask on the discussion forum. Okay, we'll stop the session here. Yeah.